we're going to be talking today about the models of speech production. Now, why is it important to understand the models of speech production? People try to simulate different ways of how we actually produce speech in order to understand how we produce speech. There are lots of theories on how we produce speech, so researchers end up testing those theories with models to see how we actually produce speech. Now, it's important to understand that because then we can say if there is an error in our speech production process, can a particular model support or help us find out where the error lies in the speech production process if we knew how the speech was produced. Does that make sense? So all we're trying to understand is there are different models in speech production. Everybody has a different way. They've tested different ways. There is no one way to produce speech. There are different models. And so ultimately, I think what I'm going to end is going to say that it is a culmination of all of these models that are proposed that will help us understand speech production. Okay. Before we understand that, I said theories, then I said models. So let's understand what is the difference between a model and a theory. When we talk about a theory is just a statement about a particular phenomenon. When you put that statement or when you propose that statement, there are certain underlying principles and assumptions that you will use to state that particular phenomenon. Okay. So for example, for me, everything that comes up easily is my phonatory system because I work with the phonatory system, voice and larynx most of the times. So one of the theories was that vocal folds vibrate due to mass and stiffness present in somebody's body, which is the vocal folds. So that was the theory that suggested that the vocal folds vibrate due to the presence of mass and stiffness, right? Now, this theory, you can propose a theory and you can leave it at that, but a theory can be tested and this theory will be subject to change with more data. Okay, so for example, if I propose the theory that vocal folds vibrate because of the mass and stiffness present in its body. When I test the theory, and I found that it's not really the stiffness, actually, the new theory, I should say, it's not really the mass that helps, it is more the stiffness is what the new theory has come up. So the theory can be subjected to change if we had more data, and of course the theory can be tested, right? So if you've heard about theory on gastric ulcers, if this was a class, I'll ask you what are some of the common causes of gastric ulcers. The first few things that come up is acidic spicy food, stress, and things like that. Those could be precipitating factors or those could be aggravating factors of gastric ulcers, but the main reason for gastric ulcer is the presence of a bacteria, H. pylori, in your stomach wall that causes gastric ulcers. So that theory, which was because saying people, because of the food that you eat, acidic, spicy food, or because of stress, those could be aggravating factors. But the theory changed from the assumption that it was due to stress to the assumption that it is because of the bacteria, H. pylori. Do you see the difference? So a theory is just a statement. It incorporates certain underlying principles. A theory can be tested, and with the data that you get from testing the theory, a theory can be subjected to change. Okay. When we talk about a model is a simplification of a system. So for example, if I talk about my vocal folds again, if I wanted to study the vibration of the vocal folds, I'm going to simplify the system. The system has a lot of things, but I'm going to simplify this vocal fold system into just a block of mass and a block of stiffness. And I'm going to study how that block of stiffness and how that block of mass is going to help me in vocal fold vibration. That becomes a model. That model is testing a theory, right? The theory is the vocal folds vibrate with stiffness and mass. It's a representation of a phenomenon. Okay. The key thing to understand with the model is it can be manipulated in a very controlled manner. So I can keep the mass the same, I can vary the stiffness and see what happens to vocal fold vibration, or I can vary the mass, keep the stiffness constant and see what happens to vocal fold vibration, or I can vary both of these in a very controlled manner to see what happens to vocal fold vibration. So I will be able to manipulate this model in order to understand how I can simplify a system as complex as the vocal fold vibration and arrive at understanding that phenomenon of vibration. Okay. A model can be physiological model, mathematical model, or mechanical model, like the 2 mass model or the 16 mass model of vocal fold vibration was more a mechanical model that helped us understand vocal fold vibration. A theory can be tested with a model, and I have said here about the 2 mass model of vocal fold vibration. The 2 mass model became a 3 mass model, then it became a 16 mass model, a 32 mass model, and so on. So that theory kept changing with what mass was required for vocal fold vibration, but ultimately I think a very recent article said mass does not play a huge role in vocal fold vibration, which is very interesting after all these years of research. So, a theory is a statement about which uses underlying principles and assumptions. A theory can be tested. A theory can be changed based on the data that we have. A model is a simplification of a system. It helps us understand a phenomenon of what we want to study. The key thing is it can be manipulated in a very controlled manner, and you can test a theory with a model. Today what we're going to talk about is the models of speech production, so which means we're simplifying this model of speech production. We're simplifying the system of speech production. And we're going to study how the simplified system helps us understand. And there are various ways of simplifying the system, as you can see when I talk about the different kinds of models. And how does it help us in understanding speech production? But before we do that, I'm going to address about 3 issues, or I'm going to bring about 3 issues that needs to be addressed by speech production models. Those 3 issues are serial order issue, degrees of freedom, and context sensitivity problem. So there are 3 issues. Anytime you look at a model of speech production, you need to know if those models of speech production are addressing all these 3 issues, or they're addressing only one issue or more than one issue. Okay? So what is the serial order issue? Now, if you think about speech, we are combining linguistic elements or phonemic elements in a sequence. So for example, think about the phonemes k, t, and a, right? Now, I can use the same 3 phonemes in different orders to produce different words. So for example, cat is k, a, t. Tak is t, a, k. And act is a, k, t. So how you see how the position, whether it's the initial, medial, or final, has been interchanged in those 3 different things. So speech is how you string these phonemic elements or linguistic elements in a serial order. The order of how you put these phonemes is going to determine how the word is perceived. If I wanted to say cat, but I ended up saying act, I'm missing the whole meaning of what I wanted to convey. So the order in which you're stringing these phonemic elements is very important to convey the meaning of speech production. That's what speech production is all about. You convey information in how you produce your speech. The theory behind the serial order issue, remember, theory is a statement with underlying assumptions, is speech organization phonemic or syllable sized? Okay, so are we saying since we have to just combine all these linguistic elements in a certain order, is speech as simple as just putting them in is speech organization as simple as phonemic or syllable sized? Okay. All right, it can be tested with a model, and we can talk about more of which models that have addressed these issues, or which models have considered or taken into account these issues when we talk about different models of speech production. So what is a serial order issue? Speech is a sequence of linguistic elements, right? You're producing the phonemes in a certain order to convey what we want to convey. If we change the order, it's going to change the meaning of what we wanted to convey. So the theory behind that is a speech organization, phonemic or syllable sized. Okay. What is the next issue that needs to be addressed? Is called the degrees of freedom. Now, each muscle contraction, if you think about how we produce a speech, if you think about how many articulators we move, how each of those articulators have different muscles, go back to the anatomy of speech mechanisms and think about all those muscles involved in tongue, the intrinsic and extrinsic muscles of the tongue. Think about all the muscles surrounding the lips, right? The upper lip elevators, the lower lip elevators, the upper lip depressors, the lower lip depressors, the retractors of the lip, right? And then think about all the muscles of the palate. Think about all the muscles, of the soft palate, the velum, and think about how many muscles need to be involved when you're producing a particular speech sound. It's not as simple as just stringing different muscle contractions and producing those speech sound. So when we talk about degrees of freedom, each muscle movement is considered, or each muscle contraction is considered a single degree of freedom. So think about how many degrees of freedom are going to be involved in all those muscle contractions that are going to be there to produce a particular speech sound. So, for example, if I had to produce the sound B, right? B involves vocal fold vibration, which means you need adductor muscles for the vocal folds to adductor muscle contraction to bring the vocal folds together because it's a voice sound. I need the muscles of the lips to come. I need the lower lip elevators and the upper lip depressors to bring my muscles together to bring closure. I need my velum to be closed because it's not a nasal sound, it's an oral sound. So think about all of these muscles, and each muscle that contracts is a degree of freedom. So imagine the enormous degrees of freedom because of the various muscle contractions that use different times of contractions, different directions of contractions, different locations of contractions. So if I thought about all those enormous constructions, and if I thought about each degree of freedom to be applied to each muscle contraction, and it had to be in a sequence, oh my God, that's just way too much, right? So we need to understand that we have to, if I would say, do we need more degrees of freedom or less degrees of freedom to produce speech? I would say we need to see less degrees of freedom to produce speech and not more degrees of freedom. Meaning, how can we combine these muscular contractions to be able to decrease the degrees of freedom? Okay, so far we talked about two different issues that need to be addressed in models of speech production. The first one is I'm jumping to the third one. The first one is a serial order issue. The serial order issue is when you have stringing of linguistic elements or phonemic elements in a particular order. You have to produce a speech to make sense if you actually combine them in the order that they would make sense. So if I wanted to say cat, I have to put the phonemic elements k, a, and t, not t, a, and k, right? That becomes tack, right? Now, the next issue that we talked about is the degrees of freedom. A single muscular contraction that we do to produce any kind of speech was called a degree of freedom. So each muscular contraction is called a degree of freedom. So think about all this muscular contraction that happens, and if I just did every muscular contraction in isolation to produce a particular speech sound, then there's going to be enormous degrees of freedom where the contractions are going to happen in different times or different directions or same directions of contraction. So our goal has to be to decrease the degrees of freedom and not increase the degrees of freedom. The third, oops, did I miss something? Yes, I did. Oh, no, sorry. The theories that talk about the degrees of freedom, I apologize. The theories that talk about the degrees of freedom is speech motor system programs separate motor signals for each muscular contraction. So which means from the brain, you're getting different motor signals for each muscular contraction. So imagine how many motor programs need to be there in your brain to provide for each muscular contraction a separate motor signal. Another theory is the hierarchical muscular control, meaning higher level controlling the lower level. A hierarchy saying, okay, the fine muscle groups will do more while the gross muscle groups will do less, so things like that. Another theory is how we can reduce the degrees of freedom is if you can combine the muscles based on their function. So if you can combine all the depressors together, or all the elevators together, or all the retractors together, that is one way of reducing the degrees of freedom. Another way to look at it, or another theory, is that muscles work in groups, but they do not work individually, which I think will make more sense, because if you were thinking about each muscular contraction happening individually for every single time, I think our speech will be really slow. I don't think there'll be any coordinated speech. So muscles have to work in groups rather than individually. Okay, so for the first thing that we talked about, which is the serial order issue, the theory is speech organization syllable sized or phonemic sized. Then we talked about the degree of freedom, and we said there are various different theories to address these degrees of freedom, and some of them are here. Muscles work in groups rather than individually. There should be reduction of the degrees of freedom if you combine the muscles in terms of their function. There's a hierarchical muscular control, or there are separate motor signals for each muscular contraction. And we'll talk more about how certain models tested these theories, okay? Final thing is the context sensitivity problem. The context sensitivity problem is very simple. Remember we talked about co-articulation. Co-articulation is when two speech sounds are produced at the same time in order to achieve our final output, right? Like where you're moving different articulators at the same time to produce two different speech sounds. For example, the example I gave was to, where my lip rounding is already happening when I'm producing the sound t in order to make sense, because you don't want to go t, you don't want to do that, then it's not even going to sound as two, right? So context sensitivity is sound varies with context, so there is co-articulation. It varies with speaker. I'm a good example of that. My rate of speech is pretty fast, right? My stress patterns are different, and I have an accent, so my sound clarity is different, or my sound production is different from how a Native American English will produce speech. But with respect to context, even though my vowel sounds or my stress patterns are sometimes different, you get the picture, or I am, to the most part, at least I consider for the most part, that I'm intelligible because I have this context thing. You understand me based on context. The key factor is that there is a lot of variability in speech production. Okay, speech production is not invariant. Okay, there is a lot of variability in speech production. So three factors that we have talked so far include serial order issue, degrees of freedom, and context sensitivity problem. Okay, these three issues will have to be addressed in models of speech production for us to understand how we are producing our speech. Okay, so the model, remember we talked, it depends critically on the assumptions of its formation. So as I said, theory has underlying principles and assumptions, and then you're developing a model based on the theory. So which means, what is the nature of input? What is the key assumption of that theory to help us construct a model is very important. So for example, if I said vocal folds vibrate based on mass and stiffness of the vocal folds, in my input, I need to have my key assumption that the mass and stiffness are very important. So I have to use those as my input in order to change anything to understand vocal fold vibration. So a model depends critically on the assumptions of its formation. The nature of input is going to be your key assumption. So for example, the mass and stiffness will be my key assumptions in understanding the vibration of vocal folds. Okay. Excuse me. An overview of different models of speech production. There is something called a connectionist model. There's something called a dynamic systems model. There's a feedback model. There are target models of speech production models, and language behavior. There's a interrelation between speech production models and language behavior. And there are certain neural models of speech production. Now, before we go on to talk about each model of speech production, I want you to think about what a theory is. I want you to think about what a model is. I want you to think about the three issues that a speech production model will need to address. They are the serial order issue, the degrees of freedom, and the context sensitivity problem. The degrees of freedom have to be reduced in order for us to have a coordinated speech production. In terms of serial order, we have to follow a particular order of combining our phonemes in order to make sense. And context sensitivity is that our speech is so variable that it needs to account for co-articulation, it needs to account for rate of speech, stress patterns, or dialectal changes of a speaker. All right.